Hello everybody, today I can use coordinate geometry to prove triangles are isosceles by proving the two sides are congruent, and triangles are right by showing its sides fit into Pythagorean Theorem using the distance formula. So, we are now moving into full coordinate geometry proofs. This is the first lesson in full coordinate geometry proofs. There's going to be 3 components to it. We're going to get started. Now, in fact, I'm sorry, before we get started, let's just get started. So we're going to compile this big how do you prove list, but for today we're just going to do 2. We're going to do isosceles, and we're going to do right. So to prove a triangle is isosceles, we're going to prove it has 2 congruent sides. And in order to do that, we're going to calculate 2 distances. And in order to prove that a triangle is right, we're going to prove its sides fit into Pythagorean Theorem. And in order to do that, we are going to calculate 3 distances. So, the first problem here wants me to prove that it's an isosceles triangle. So the first thing I'm going to do is I am going to plot my points. M is 7, -1. E is 2, -2. T is 3, 3. And in order to prove it's an isosceles triangle, well, my step 1 is going to be that MET is an isosceles triangle because well, I can flip back to the notes here because it has 2 congruent sides. So that's going to always be step 1. You're going to state what they want you to prove because, and if it's isosceles, it's going to always be it has 2 congruent sides. So now I'm going to have to calculate the distance of those 2 congruent sides. Now this one's not obvious which one it's going to be. So to me, it looks like ME and ET. I could be wrong. And if I'm wrong, then I'll just have to calculate the third. So I'm thinking ME, and I'm thinking ET. So distance, we've been doing quite a bit at this point. If you're not comfortable with distance, go back to the distance lesson. Distance is radical delta x squared plus delta y squared. So ME is 1, 2, 3, 4, 5, 1. 5 squared is 25. 1 squared is 1. That's rad 26. ET is 1. 1, 2, 3, 4, 5. 1 squared plus 5 squared. That's rad 1 plus 25. That's rad 26. I wanted to show it has 2 congruent sides. I showed that these have the same distance. Now step 3 ties everything together. In step 1, I said it has 2 congruent sides. So tell me, what are the 2 congruent sides? I'm going to say that ME is congruent to ET because they have the same distance. And we did mini proofs of this a week or so ago. So you can watch proving segments congruent. In order to prove segments are congruent, I calculate their distance. I show that they're the same. I say they're congruent because they have the same distance. So component 1, you're going to state what they want you to prove. Met is an isosceles triangle because, and then you kind of go to your how do you prove here. It has 2 congruent sides. Then you're going to find the distance of those 2 congruent sides. And then you're going to tie it all together. If you're telling me that it has 2 congruent sides, tell me what 2 sides are congruent because they have the same distance. Number 2. A 0, 10. B is 5, 0. C is 8, 4. It wants me to prove that triangle ABC is a right triangle. So this is different than the previous question. The previous question said to prove an isosceles triangle. Here it wants me to prove that triangle ABC is a right triangle. Well, I start by saying triangle ABC is a right triangle because. We always start by stating what they want us to prove because. Go back to your list here. Have this written down. It's in the front of your packet, all of the how do you proves. But definitely have this in front of you and next to you when you're doing these because its sides fit into Pythagorean theorem. Now, in order to do this, we're going to have to calculate the three distances. I'm going to find the distance of BC. I'm going to find the distance of CA. And I'm going to find the distance of BA. That C does not look like a C, so I'm going to fix that. It's bothering me. That's better. All right, BC, 1, 2, 3, 1, 2, 3, 4. That's rad 9 plus 16. That's rad 25. I'm going to leave it as rad 25 instead of making it 5, and you'll see why afterwards. CA, 1, 2, 3, 4, 5, 6, 7. 1, 2, I'm sorry, 8. 1, 2, 3, 4, 5, 6. 8 squared plus 6 squared. 64 plus 36, rad 100. And again, I'm going to leave that as a radical. You'll see why afterwards. It's going to make my next step easier. BA, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 5 squared plus 10 squared. That's 25 plus 100. That's radical 125. Now, in step 1, I said that its sides have to fit into Pythagorean theorem. So now I'm going to substitute those sides into Pythagorean theorem. A and B are the legs, the shorter sides. C is the hypotenuse, the longest side. So the rad 125 is the biggest, so that has to be C. So it's rad 25 squared plus rad 100 squared equals rad 125 squared. Now check out what happens in this next step. When I square a radical, the square and the radical cancels. So I'm left with 25 plus 100 equals 125. 125 equals 125. I've shown that the sides fit the Pythagorean theorem. And that's why I leave everything in radical form, because when I square the radical, they cancel, and that just makes the problem a lot easier. So what do? To prove a triangle of isosceles, we show that it has two congruent sides. I calculate the distances, show that they're the same. Then I state that the sides are congruent because they have the same distance. To prove that a triangle is right, I'm going to show its sides fit into Pythagorean theorem. I'm going to calculate the distances. I'm going to substitute those into Pythagorean theorem, and the square and the radical always cancel. And again, as you're doing this, make sure that you just refer to this because everything you need to know is right here. All right, we're going to take a look at one more. Number 3, triangle JOY has vertices 4, 0, blah, 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 blah. Let's get that information into the picture. It wants me to prove that J of Y is an isosceles right triangle. So there's two parts of this. It wants us to prove it's an isosceles right triangle. So I have to prove it's isosceles and prove it's a right triangle. So Joy is an isosceles right triangle because I want you to take about 20 seconds and finish that sentence. And as a hint, you're going to be looking at this page in order to do that. Joy is an isosceles right triangle because, well, it's isosceles because it has two congruent sides. And it's a right triangle because its sides fit into the Pythagorean theorem. So now, step 2, I'm going to have to calculate the three distances. I'm going to have to calculate the distance of YO, the distance of OJ, and the distance of JY. I want you to pause, find those distances, and then unpause. Okay, now that you calculated those on your own, OY, 1, 2, 3, 4, 1. 4 squared plus 1 squared, 16 plus 1, that's rad 17. OJ, 1, 1, 2, 3, 4. And in general, with these coordinate geometry proofs, you do always want to leave things, you don't have to reduce the radical, just kind of leave them in radical form. JY, 1, 2, 3, 1, 2, 3, 4, 5. Now, part 3 is going to tie everything together. In part 1, you said that it has two congruent sides. Tell me what sides are congruent and why. In part 1, you said its sides fit into Pythagorean theorem. Show me its sides fit into Pythagorean theorem. Pause. Try and do 3 on your own. As a model, look back at number 2 for how to show its sides fit into Pythagorean theorem, and look back at example 1 to show how we do the two congruent sides. So again, right now, try to do part 3 of number 3 on your own. So please pause, complete step 3 on your own, and then unpause. Okay, so in part 1, I said it has two congruent sides. Well, these two are congruent. YO is congruent to OJ because they have the same distance. Show its sides fit into Pythagorean theorem. Well, I'm going to start by writing a squared plus b squared equals c squared. A and b are the legs, the smaller sides, the rad 17 and the rad 17. C is the hypotenuse, the longer side, rad 34. And again, in the last example you saw, when you square a radical, the square and the radical cancels. I'm left with 17 plus 17 equals 34. I'm left with 34 equals 34. Boom. You're always calculating distance for these. So that's the entire unit. You're going to always be calculating distance with one exception, but we're not worrying about that exception yet. So that's it. Your classwork/homework is to finish this worksheet. There's just one example left to prove a triangle is isosceles, prove it has two congruent sides by calculating distance, prove a triangle is right, show its sides fit into the Pythagorean theorem by calculating those three distances. Have a great day. Enjoy the rest of your day and practice. Bye.